Hi, my name is Katie, and I'm the driver for the session, and I'm here with.
Hi, my name is Ronnie. I'll be navigating this session.
Okay, so I am going to go over the try it yourself today. So basically, um we are going over chapter 9, which was sorry, not chapter 9, chapter 11, which was working with dates and times. Okay, so yeah, we've got the try it yourself. So number one, using the unique city taxi data, calculate the length of each ride using the pickup and drop-off timestamps. So the query results from the longest ride to the shortest. Do you notice anything about the longest short or shortest trips that you might want to ask the city officials about? So moving to PG Edmond, I have already um created the formula, so I'm just going to explain what it does. So with filter trips as on line 148. Over there, it just defines a temporary result set called filter trips. You can reference this virtual table in a later query, just like a regular table. It also helps keep the code clean and modular, especially useful for the complex analysis. Inside the CTE, extract epoch from basically line 150. Um, this just calculates the duration in minutes. So the extract epoch from that gives the difference in seconds, and dividing it by 60 to convert it in minutes. Um, and then it also just renames it as trip time minutes for clarity. And then we have the trip distance total amount. On line 151 and line 152. So this just selects the distance traveled and the fare charged for each trip. These are variables we'll analyze later, like the correlation and the regression. Um, then we have the from NYC yellow, line 153. This just pulls the data from the New York City taxi trip. They were from June 1st, 2016. And then we have the way extract epoch 3000. I mean 3600 line 154. So this filters out the trips longer than 3 hours and 180 minutes, and then it removes the outliers that could distort statistic um analysis. So now I'm going to run the query and we will see the output. Wait, why? What am I missing? What? Oh, why is it? Oh, syntax error. Hmm, this thing. Um, so when I run this, I should get the output. So let me run it real quick. Oh, over here is the output. Moving on, we have question number two. Using the air time zone keywords, write a query that displays the date and time for London, Johannesburg, Moscow, Melbourne, and the moment January 1st, 2100 arrives in New York City. Okay. So let me explain that code. So, hmm. So over here, this code basically, let me just highlight it. So over here, basically, the time stamp 2100 for New York creates a timestamp within the time zone from midnight on January 1st, 2100 in New York City. And this is the reference at the moment. And then for London, it converts and extracts the moment to London's local time. And the result shows what time it is in London and when it's midnight in New York City. So the same logic applies to Johannesburg, which is the local time, and then Europe, which is also the local time, and the same for Australia. So basically, when it's exactly midnight on January 1st, 2100 in New York, what time these cities are on. So I'm going to run it and we will see. So over here we can see for London, for Johannesburg, for Moscow, and for Australia. Moving on, we have question number 3. Is a bonus challenge. Use the statistics function in chapter 10 to calculate the correlation coefficient and R squared values using the trip time and the total amount column in New York City taxi data, which represents the total amount charged to passengers. Do the same with the trip distance and the total amount columns, limit queries rides that last 3 hours or less. Okay, so over here we can see the formula. So the core is correlation trip time. Um, Let me just see something. Basically the trip time minutes. Um, so basically that is the duration of the ride, and then the total amount is just the fare charge. And then let me just run this along. And then the results ranges from -1 to 1. The 0 is no correlation, and the -1 means a perfect negative correlation. And then we have the REGR R2. This just, this just calculates the R2 value from the linear regression. It measures how the trip time minutes predicts to the total amount, and it ranges from 0 to 1. 1 perfect fit, 0 predictive power. And then the core trip distance total amount, same as above, but the trip distance versus the fare. And then the REGR R2 total amount trip distance, that is the value for distance predicting the fare. So where is the clause? So it is over here, line 169. It filters out the trip for longer than 3 hours, and then it removes the extreme outliers that could distort the correlation and R2 values. And I've already run it so we can see the correlation, the trip time, the distance, and the R squared. And that is it for chapter 11. Thank you for watching.